Good morning, everybody who managed to come here so early in the morning after the party, even those who are late. Thank you for coming. Today, we'll be talking about Docker revolution. My name is Michał Poręba. I am an explorer. I explore flooded caves and new technology. Today, we will be talking about technology. I work as a senior DBA at Visolution, which is a company in Wales doing sort of software as a service. So it's mostly a software development house. So as a DBA, I get to work a lot with developers. So the DBA's world used to be very simple. For years, for the last probably 25 years, it was Windows and SQL Server. Quite recently, Azure as well. But it was just that. Windows domain with Windows servers running SQL Server. Everything was very easy. But in the last few years, a revolution has started. We've got Docker, and with Docker comes a lot of things. We've got Docker Swarm, Kubernetes, we've got Portainer, Helm, and as every idea nowadays worth having needs to have a logo. So there will be quite a few of those. There is Git, GitLab, GitHub. We've got Linux now in the picture as well. Red Hat and Ubuntu supported right now. We've got Jenkins, maybe you've heard about that. There is an Octopus deploy. They can work together or independently. There is the concept of DevOps, which everybody's talking about right now. There is obviously Azure DevOps. There is Azure, there is pipelines, a long list of new words like containers, GitOps, DataOps, continuous this, continuous that, pipelines, planes, pods, and somewhere among those there is still the SQL Server. So how do we make sense of all of that, and where do we start to explore this new technology? Let's have a look. So what is this talk about? It's not about the logos from the previous slide, not about all of them. But what I want to do, I want to talk about containers, I want to talk about Docker, Docker Swarm, and SQL Server, and how those things fit together so we can start exploring all those other things. And I will try to explain why I think it's worth to deal with the problems, and there are problems using SQL Server and Docker together, why it is worth to still try it and get some of the benefits. So let's start with containers. What is a container? It's simply an abstraction on the app layer. It allows us to contain applications with their dependencies so they can be redeployed to multiple environments without worry those dependencies will interact or interfere with each other. It's a next logical step from virtual machines. The virtual machines virtualized hardware. So we could share the hardware between multiple operating systems. With containers, we can now share the operating systems safely between the applications. Just quickly, so that's how virtual machines used to look like. There is some hardware infrastructure, there is hypervisor, and we've got number of guest operating systems. Though guest operating systems are fairly big, they take a lot of resources in themselves. So the containers try to solve that by installing the Docker layer on top of the operating system, host operating system, and then the applications can share the underlying operating system without that duplicity. So what is Docker? Docker is the application that makes it all possible. That's not the only application, but definitely the most common, and pretty much the only one that matters at the moment. And also the company that builds that application. It all started in 2013, has been a while, and it's a real revolution. If you look at the version numbers, in April 2019, last month, we had version 18.9 in 6 years. A lot of new development. So let me show you how it works. So what we can see here, I've got a container running. Few things worth pointing out, if I can see what I'm doing. Okay, we've got an image. It's an old Windows image with SQL Server. We've got information that it's been running for up 40 hours, and we can also see that I'm mapping port 1433 from my machine to port 1433 within the container, and also that I've named the container SQL. So I also want to show you that although I have installed a local instance on my machine, it is all stopped. Nothing's running here. So the only SQL server I've got at the moment is in the container. Let's try to connect to it. There we go. Is it big enough? Maybe I'll make it slightly bigger. I'm running a developer edition, and in the container I've got Windows Server 2016 data center. That's easy. Now let's try, everybody's talking about it, Linux containers. So this one is on Windows, so let's try a Linux container and see how this goes. So here is my command, and very basic command. There's many resources to explain you exactly how Docker works. There was a session yesterday as well, so maybe I won't go into too much detail about the commands, but what I want to point out is that basically we are saying to Docker, please run this image provided by Microsoft, and it's SQL Server 2019, CTP 2.5, and it will be on Ubuntu. So let's see what happens. If I can. Right. So we've got some problems. That's expected. I wanted to show you how to deal with problems, because starting with new technology, you will find problems. So what we've got here is information that here. Image operating system Linux cannot be used on this platform. I'm running Windows containers at the moment, and I cannot use Linux containers. At the moment, quite recently, it is now possible to run containers on both at the same time, but you can control them one at a time. So I will let it run this existing image, but I will switch to Linux containers. I'm being informed here it will take a moment, hopefully not too long. So now if I clear this and do docker info, let's have a look. Now, I've got information that I'm running operating system Docker for Windows. I'm still running on Windows, but my OS type for the kernel is Linux. The kernel version is Linux Toolkit here. So let's try again, if we can make this run. The command didn't return any errors. We've got this long number at the bottom, which is the identifier of a container. So let's have a look if it's running. And if you ever seen any demo, that Docker PS lists all the available containers which are running, and you can see there is nothing there. So that's another problem. If you have experience with SQL Server, if you are a DBA with years of experience, natural thing would be to go to the logs. But because the server is within the container, and as I said at the beginning, the whole purpose of containers is to isolate everything, you won't see the logs on the local disk. So there are many ways to connect to the container, see what's inside, but only started containers. But there is a command which helps us with errors. Docker logs, and we'll do the number of this container, and there we go. Now, there are some error messages. server tells us we need to accept end user licensing agreement. So let's do that. And also we will need to set up SA password. Should probably follow the advice everybody gives me, do not type on live demos. Still doesn't work. But I'm not using the name of a container. Probably yes. No? Okay. First time it didn't work, but I won't be able to show you. I've got another instance which I created yesterday, so I'll just start that and show you instead. That's something I did not expect. Okay, we'll have to move on. There's plenty of more demos. So we were able to connect to Windows container. Linux container for the first time ever failed on me. So apologies for that. Let's go back to the presentation. So, yes, I wanted to show you that we can run SQL Server on Linux in any container, and you will have to trust me on that. It normally works. There are a few commands to learn. What I wanted to show you that behind that Docker PS, Docker start, Docker run, Docker logs, it's just normal SQL Server. So it really is the same. It is actually the same binary. So most of the features, unless they depend on other external processes, they will work. Deploying new SQL instance normally takes seconds, but we've seen SQL authentication. Now, that's a step back. In Windows domains, preferable method is to use Windows authentication. So why is that? Why everybody's showing you SQL authentication in all of the demos? Now, let's see what happens if we try to connect with SQL authentication. Sorry, yes. So I've got my Windows container, and I will try to manage, disconnect. To recreate it. So I'm connecting to the local host on port 1433, which is my Windows, and I will choose Windows authentication. Now let's see what happens. We are getting connection error, failed to generate SSPI context. Now, what does it mean? It will happen exactly the same on Linux. It is the same problem. So what is it? To explain that, we have to talk about what SSPI is. Security Support Provider Interface, which is a Win32 API that deals with trust between different computers on the network. To understand that, we will need to explain FQDN and SPN. FQDN is fully qualified domain name of a host or service, and the SPN is service principal name, which is, in the case of SQL Server, it is made of MS SQL SVC / the fully qualified domain name of a server and port on which it listens. Now, here is important information as well. Docker hosts can be on the domain, but the containers cannot. So the SSPI authentication within a Windows domain. We've got three elements. We've got an Active Directory user, we've got Active Directory domain controller, and a SQL server. Now, how the authentication happens? The user will contact the domain controller, providing fully qualified domain name of a server to create a service principal name and initialize security context on domain controller. That will return a token, which that token then is passed to SQL Server, saying I'm authorized to make the request. But the server won't just trust it. It will go back to the domain controller and validate the security context. And if everything's fine, it will respond back saying, here is your data or whatever we requested. Now, when we have SQL Server in the container, remember that container can, the Docker host can be on the domain, but the container itself is not. So what happens, the user goes to the domain controller, providing fully qualified domain name of a container of which domain controller doesn't know anything. So the domain controller says, well, your context is wrong. That's it. End of story, it doesn't work. Now, so how do the containers fit into our networks? Windows networks, not so well at the moment. There are ways to work around it, but so far, from what we've seen, they're not working very well. And yet, there are many use cases where it's fine. So for local development or test environments, scenarios where SQL authentication is fine, they are very, very useful. And from my experience, we use those in test environments. In my local development environment, if you want to try new features of 2019, that's pretty much the only option. You just install it in the Docker container, and so be it. If you need to use a SA password, fine, it's a local instance, there is no sensitive information. You stop playing with it, you just shut it down, problem's gone. And there are many benefits of using it as it is right now. For testing, you can have multiple instances. On my laptop, it's not very powerful laptop. I've been running up to 8 instances without any problems. We have the ability to spin complete environments with, say, websites, other applications that connect to SQL Server. Predefined, perhaps it's outside of scope of this presentation, but when you start up a container, when you build a container, you can pre-create the databases, populate it with data, and share it with developers. What it means, you've got an image which you can give to all developers. They don't have to share a VM. And every time you change something, you just tell them, pull the new image, and you will all have the latest changes. So let's see if we can take the next step and actually make it work with Windows domains. So to do that, I've got a test setup, which I've built in Azure using VMs, and I created a Windows domain called demo local. So I've got a domain controller, I've got a database, and I've got 2 Docker hosts called DKR, Docker 1 and Docker 2. It's easier to pronounce it that way. And I will be trying to connect from a public web browser through a website running from one of those containers, and I will want it to go get the identity from the domain controller and connect to the database. To do that, I built a test service in C#. It's a web API project. The image is available on the Docker. The slides will be available, so it's all available for you to see. We've got the source on GitHub as well. And what it does, it allows me to point at a IP with a port and query the server to see how it responds. Quickly, what it does the main code, the query part, where when I point the browser and pass database server name through the URL, it will be passed through the variable there, it will go into the connection string there, It will use trusted connection, which means Windows authentication. If everything goes fine, that query will be executed against the server, and the results will be returned. If something goes wrong, we'll capture the exception, and we will display it to the user again. So let's see if that works. So that's my Docker host. So let's see if the container is running. So here we can see on port 8001, I've got a test service, which was used with my SQL GMSA test image. So that runs. So let's try that query. Okay, so we've got an exception. Login failed for anti-authority anonymous login. Not quite what I wanted. Why? We've got a user, external user, that goes to a container, and that container makes the request again to the domain controller through the Docker host. And this time we don't have a problem with SSPI context, and yet we cannot get access. We got the token, it goes to SQL Server. SQL Server goes back to the domain controller, that responds fine. But yet we are getting a login fail for user anti-authority anonymous login. It is because containers are not on the domain, and the Docker host is using this anti-authority anonymous login to authenticate against. So if we created that user, well, you cannot really, but let's pretend we can, you could grant access. You could grant access to public, not very good practice, but if you grant access to public on the SQL Server, that will work. Not a solution for production. So let's see what we can do. We can use something called GMSA, Group Managed Service Accounts and Credential Spec Files. To do that, we will need to do a little bit of setup on our Active Directory domain. We need to set up key distribution root key. There's a PowerShell command for it, and you need to do it only once. And you need to be on Docker 1809 or later. Now, so what do? We need to create a group, an AD group to manage access. I call it Docker hosts. At the moment, I've got two hosts in that group. We need to create service accounts, group managed service accounts. At the moment, I've got two. I call them Service A and Service B because that's how imaginative I am. And if you don't like PowerShell, really, you can do that the old-fashioned ways with point and clicking. So you can see those two services are there anyway. So now we need to create a new one. We will create the new one. We will then get that service account to see if it has been created. We will test it on the Docker container, and we will install it with a command, install AD service account. When we create a new service account, we need to give it a name, the domain, and important part is that principals which are allowed to retrieve managed passwords. That tells the domain controller which hosts are allowed to retrieve that password and effectively use the service account. Important bit, the install AD service account has to be run on the Docker host, and every Docker host you want to use it on. Everything else is set up only once on the domain. You can use any server within the domain. It will just execute against the domain controller anyway. But the last bit, the installation of AD service account has to happen on every Docker host. So once we do that, we need to create the credential spec file. It is something that Docker introduced to help with this problem. Right now, quite recently, we've got a PowerShell module in PowerShell Gallery. So all we have to do is install module credential spec, import the module, and here I'm doing get credential spec to show you the spec files I already have. That's only the spec, what is in the spec file. So if you are concerned with security, I don't think there is the need to be concerned at this stage. All it does, it stores some almost publicly available information. There is no sensitive information here. It's an open text file saved on the Docker host, but it has SID, machine account name, a GUID, few DNS informations, that's it. So we need to create a new account, service C. It will create a new file, and let's see what happens now. I'm just trying to see if I don't have that service already from the previous runs. I don't. So what's happening here, I'm creating the Docker image again, passing it a name, test service C. I will be mapping it on port 8008. I will be using the same test image as SQL GMSA test, but I'm adding this security option. I'm saying please use credential spec file, and the file is service.c.json. There is no full path. There is no need for a full path. All we have to do is give it a file name in this format. So what will happen now? Got a new ID. That looks good. It is running 8008 service C. So let's try it. Still an exception, but this time the exception is login fail for user demo service $C. Now that's getting better. Now at least we've got access denied for a specific user. So let's see if we can actually make it work all the way. Going to the database server. Worked. Let's try again. And we've got a response. Still it says current user is guest because I haven't created any users. But I've got the login. So we can see original login demo service C is there. And from now on, everything is back to normal. We've got microservices running in Docker containers, SQL Server which is not in the container, and they communicate using domain authentication. Okay. No? Yes, demo to conclusions. So we can see that we can now run Docker containers against SQL Server on the domain, which allows us to bring this new technology, perhaps even in production environments, and integrate them with existing systems. We don't have to start with a big revolution, bring all of that Linux in, throw away Windows, and start from scratch. We can use existing SQL servers, SQL Server clusters perhaps with high availability done more traditional way, and allow the developers to use microservices in and deploy them in containers in any technology they choose. So no passwords are involved. It's much better. We don't need to allow mixed mode authentication on SQL Server. Each container can have its own identity. What it means is we can have multiple credential spec files on the host, and each container can use one of those. Now, there are some problems with it. The permissions are controlled by host. What it means is if you install that credentials, that group managed service account on the Docker host, anybody who's got access to that Docker host can go there and choose any of those service accounts to connect any service to your SQL service. Now, that's potentially a security risk. Also, they could write their own service, deploy it there, and use existing credential spec files to connect. But that's something you have to manage. Security is not trivial. There is always implications of whatever we do. So one of the ways to secure it is restrict access to Docker hosts. Typically, people don't need access there at all. Once you define those containers, not many people will need access to it. So, how do containers fit into our networks now? It's not bad, it should be bad. So it's not all that bad. It's better. We can still do what we've done before. We can have a set of containers, run them locally, we can run them somewhere else, but we can also run in production as we do, where you've got microservices and containers connecting to SQL Server outside of them using SQL authentication. So how about the next step? What if we want to have everything in the container? We already know that we've got that JSON file with credential spec. We can make it work on one end. So why wouldn't we use that on the SQL Server side and have everything in the containers? For one little reason, it won't work. That's apparently one of the reasons why SQL Server 2019 hasn't been released yet. Perhaps not the main reason, but one of the reasons. That's something they want to solve. SQL Server within the container with domain authentication, it just doesn't work yet. Hopefully in 2019 it will, but we will have to wait for it. So we had simple cases of using plain Docker containers. But on the first slide, I've shown you a lot of those logos, and some of those were about orchestration. Orchestration is one of the main reasons people talk about containerization, about containers. What it is, it's a process, a software, which allows you to have a group of services, a descriptive file that tells you, or rather the system, I want to have 5 instances of service A, 10 instances of service B, 2 instances of service C, and I want them to talk in this specific way. And it just happens. It's almost like old-fashioned composer presenting a score, and there is somebody else, the conductor, who just makes this complex thing happen. So, what are our options? In Docker, there is something called Docker Compose file. Docker Compose file is a YAML file that allows us to specify in a declarative manner which services we want to have, how many instances we want to have, few other parameters, what they are, name, CPU, memory allocation, things like that. And then, with a single command, you can bring all of that up. It's very useful for testing purposes. For example, let's say you've got a number of containers with microservices, maybe a SQL Server as well, and you want to spin up the test environment. You can do it with a one command, make sure for every person using it, it's exactly the same, and then spin it down, clean it up, do something else. It is very good for test automation, test environments, single host environments. It just works. The other option is Docker Swarm. That's something surprisingly not many people talk about. Everybody talks about Kubernetes. Docker Swarm does a similar thing. It works on multiple hosts. The way it works, you create a Docker Swarm. It's as simple as saying Docker Swarm init. On a single host, it will convert your local machine to Swarm effectively. You can then combine multiple machines into effectively a cluster, a swarm, and they can now share the workload. So similarly with what we had with VMs, that we could have multiple hosts and share the resources. Now we can share the resources across multiple operating systems through Docker Swarm. Good things about it, it was always part of Docker, well, since version 1.13, a long time ago. It works on Windows 10, it works on on Server 2016. It is available in the Community Edition of Docker. And also Docker Compose now works with Docker Swarm. So you can use Docker Compose to deploy to Swarm. Swarm is limited. It doesn't do fancy stuff with orchestration like automatic scaling. It won't look at the load and say, oh, I think I need a few more instances of that service. That's something it will not do. But still, it will maintain, if you tell it, please run 5 instances of that container, it will make sure 5 instances are running. So if one, for any reason, crashes, it will start another one. If it discovers that on a specific host, specific service keeps crashing, it will just move it to somewhere else. So it still offers quite a few things. Kubernetes. Everybody's talking about that. And sure, it's probably the most interesting thing out there. It offers a lot of advanced features. It offers auto-scaling, where it will just see, well, you need more services, I'll give you a few more services. It's been started by Google in 2014, so pretty as old as Docker itself. It is now open source, but it requires Docker Enterprise Edition. It will not work with Docker Community Edition. There are some other restrictions. We are talking here about Windows networks. Kubernetes is great on Linux. Right now, it supports Windows. But to do that, you need to be running Windows 1809. You need to be running Docker 1809 as well. And you need to be running the latest Kubernetes from March 2019, 1.14. And also, if you want to do what I've been showing you with GMSAs, you need to enable explicitly alpha GMSA features. They're marked as alpha. They're probably not production ready yet. So that's one of the reasons. Oh no, sorry, there is one more reason. A conversation stopper. It works on Windows, but only on a worker host. If you want to have a Kubernetes in your local environment, not in the cloud, what you need is 5 Linux servers. 5 servers for the control plane. And those have to be on Linux. And as far as I know, there is no plan to actually make that work on Windows. So if you run everything on Windows and you want to use Kubernetes locally, you need to learn Linux. So Docker orchestration, my choice. That's what I'm using right now. I use Compose in dev and test and Docker Swarm in production. Again, not all bells and whistles from Kubernetes, but it works. And it works with Windows. Kubernetes, that's where I want to be. It gives that a little bit extra. And as soon as it is, well, it is, and I'm ready. Obviously, you need to upgrade to the latest Windows and upgrade all the software. So it will take some time, but hopefully I will be there. Let me show you something else. Okay, so what happened here? Maybe that's what I should show as well. Give me a second. Host name, I'm on the Docker host 2, and that's a simple ping with one packet to my database server. But I explicitly want to send a packet which is 1 kilobyte inside size. It works. Nothing amazing about that. Now, what will happen if I want to send 10 kilobytes in the packet? Still works, as it should. TCP/IP has been around for a while. There are packets built of frames. Those get, if they're too big to transfer, they automatically get split into 2 or multiple ones and get delivered. So that works. But what happens if we go now to the container? So, let me see. So now I'm connecting to the container to execute command line. So now I am inside my container. So what if I want to do the same thing? One packet, 1 kilobyte in size, to my database server. It works. Now 10 kilobytes. One sent, one lost. What happens here? Let's try to find the number. So sort of a magic number is, in most cases, is the MTU, max transfer unit. Let's see what it is on this container. Net shell interface IPv4 show interfaces. And we've got on our Ethernet, vEthernet MTU is 1500. So that's default settings on setting on most of the servers. Let's see if we can send that. Doesn't work. How about less? Still doesn't work. Not to prolong it, I'll show you. It's on this VM. The magic number is 1392. This will work. That will not. Why this happens? The problem happens only on Windows. There is some problem with networking stack. And by default, VMs, and here I'm using Microsoft provided VM with Docker, and it's configured by default incorrectly. Because of that MTU set at 1500, every time the Docker needs to send a packet which is bigger than, in the case of Azure VMs, 1392, it will fail. We spent quite a few weeks trying to figure out what's going on. On our, we are running Docker in VMs in Nutanix. It's a virtualization platform. In our case, it's 1450. That number is different between different VM providers. Container tries to send a packet which is too big, and rather than splitting it, it passes it as it is, and somewhere in the network stack, the error happens, it cannot handle it, and the whole thing just falls over. In our case, we noticed it when we had a first test pre-production swarm cluster. We had 5 nodes, and all our applications were working fine. But the Docker swarm itself, once every 2 weeks or so, would just stop working. We were losing nodes. The internal communication between the swarm is affected by the same issue. And once in a while, they would just stopped working together. We had to rebuild the whole thing again. There is a workaround. It's a bit involved, so I won't be showing it. All it takes is to reconfigure that MTU value to the highest that works, and it works again. But probably better approach is not to run Docker, especially Docker Swarm, in VMs. Run it on bare metal with operating system, no problems, or Linux. That problem affects only Windows networking stack. So, a little bit of a warning. Everybody's talking about Docker, but it is the cutting edge technology. There is a lot of benefits. There are many benefits. There are problems to be had as well. Be careful who you trust. Quite recently, there was a big hack on GitHub, Docker Hub, where a lot of images are stored. People got keys that allow to deploy packages. So, in a sense, don't even trust my package now anymore. It might be that it's the same name, but somebody else might have uploaded it. Well, I've changed my keys, but the principle is the same. After that hack, you've pulled down a package, an image for a container from a source you trust, but it might be something else inside. So you never really know what's in it. So for production, what we do, we build our own images. Perhaps that's the reason why Microsoft moved their images out of overall Docker Hub repository. They host their own. So we take base Docker images from Microsoft, and we build our own images in-house, and we have our own Docker repository, and only from there we can deploy to production. Docker in a VM, even those Dockers on VM Azure. So you go to Azure, there is a virtual machine template with Docker EE. That's what I'm using. It suffers from those problems. So it requires some extra configuration, or preferably don't run them in VMs. For testing, it's fine. For production, probably you waste a lot of resources, which you are trying to save by using Docker in the first place. And mostly those are around Windows and its networking stack. SSPI context problems, you've seen it can be worked around using group managed service accounts and credential spec files. That works in containers on standalone containers. It works with Docker Swarm. It has been just introduced as an alpha feature in Kubernetes. There is a very good description how to set it up, but it's a very long description. So have a go. If you make it work, let me know. I haven't tried that yet. Remote server administration toolkit, Active Directory, PowerShell module. I've spent a lot of time trying to make it work. Longer description is on my blog if you are interested. But what happened there, that command we have shown you, add service account, and it has principles allowed to retrieve managed password. There is an equivalent of that which is set. Either of those does not update existing record. So that's why I'm using right now group for containers. I had the situation where I had 3 different VMs with different versions of systems. I wanted to see what works, what doesn't. And I made it work on the first one, and then I moved to the second one. I struggled, so I came back to have a look again if it works on the old one, and it stopped. And for about a week, I was able to get only one of my VMs to work at the time. Every time you run that command and say, that is the host which is allowed to access that password, it removes the permission from everybody else, every other host. And you're back to the SSPI context problems, but the error message is slightly different. It doesn't make much sense in that context. You will run the get AD service account command on the Docker host. It works because it just retrieves the account. You can it's installed. You can test it. it tests fine because the account is there. It's just that that server doesn't have access to the password. So when it's needed by the Docker host, it will fail. So if you want to play with that, something to keep in mind. And that's a bit faster than I expected, but that means I've got time for questions. This presentation is available there. That's my blog where I write more about this sort of stuff. If you have any questions later on, I'm on Twitter as well. I respond in English, Polish, Welsh, German not so much, but you choose. I'll be fine. So any questions? Dziękuję. Thank you very much.